This is 4.2 degrees in radians. So the first thing we're going to do is we're going to look at an angle. So let me see if I can draw. So we have an angle. Ooh, let's make it thicker. I'm going to make my pen thicker. Okay, so this in here is what we call theta. That is our angle. This side right here, that is always attached to the x-axis, so it will always be on 0 degrees. And we call this the initial side. And then this is our terminal side. That is the one that will swing. So we've got two different kinds. Okay, now we're going to look at two kinds of angles. So let me draw. Okay, so here is my coordinate graph. So we are always going to have our initial side, here let me make it in pink, at 0. We have two kinds of angles. We have positive angles, which go counterclockwise. Then we have negative angles, which go clockwise. Okay, so bear with me. Okay, so I'm going to put, hold on a second, okay. So, I'm going to, okay. So now for your positive angles, you're going to go in the counterclockwise direction. So you're going to go this way in this direction. It's always going to go this way. We'll always go, oops, me right. We'll always go this way. Okay. Whereas, give me a second and let me draw this again. I'm going to make this one pink. Okay, so let me draw one over here, move it. Let's make it pink. Oh, maybe not. Okay. Let me undo. Let's undo all that. Okay. Let me try this again. Okay. I'm going to put an arrow on here. Let me move it to here. So now, for our negative angles, you are going to go in the clockwise direction. So they are going to go this way. Okay. Okay. The next thing to keep in mind, let's go back to from our days of geometry. So in geometry, oops, let me undo that. Okay. So if I have a circle, my circle is 360 degrees. So half that, okay, I'm going to attempt to draw this. So half of it sorry, I don't have a button on here that does semicircles. So half of it is 180 degrees for my semicircle. And 360 is equal to 2 pi, so it's all the way around, and 180 is pi. Okay, for our next demonstration, while we're waiting for this website to pull up, you're basically going to look and see what a radian is. So I'm waiting for it to pull up. Give it a minute. This is the only way I could get this one in there. Okay, so I'm going to move. Oops, hold on. Oh. Alright, so I gotta figure out how to move. Okay, I gotta figure out how to do this. Okay, here we go. I was trying to figure out how to get this thing to work. Okay, so if you look at this example right here that we're looking at, Many people are confused about what radians are. Here's a GIF. So basically, it comes out and it draws the circle with a certain radius. Okay, and then it's taking this and it's taking that radius and putting it along the outside edge. And you'll notice that it can basically put the radius out there one time. Now it's going to take it and it's going to put that radius will fit around here 2 times. And then it will do it a 3rd time. And you notice it quite doesn't fit all the way around the circle. It fits around 0.14 amount of times. So that's why half of a circle is pi. And then if you keep going again, it'll be 2 pi. So basically, it will fit around the radius that was here. That was right here. Will fit around your circle 6.28 times, or 2 pi. Or to fit around half of your circle 3.14 times, which is pi. Okay, next I want to basically convert between degrees and radians. Okay, oops. Send that out. Okay, so now I want to convert from degrees to radians. So if I want to convert from degrees to radians, if I want to go from degrees to radians, you're going to multiply by pi over 180. If I want to go from radians to degrees, you're going to multiply by, oops, let me put it on here. You're going to multiply by 180 over pi, because pi is 180 degrees, and so we're basically just doing unit conversion. So it's kind of like when you're in science class and you have to do dimensional analysis to convert things. Okay, so next I want to give you some examples. So if I want to do 120 degrees and convert it to radians, we have to figure out, so if you forget this, you want to figure out how to get things. So if I want to get rid of my degrees up here, I means I need to have a degrees down here. So that means I need 180 degrees down here. 180 degrees is pi. Your radians should be in terms of pi. And when you do that, your degrees cancel out. You're left with 120 pi over 180, which if you reduce that, that gives you 2 pi over 3. And that's that in radians. 2, if I want to try another one, negative 45 degrees. We're going to multiply that by, again, 180 degrees equals pi in order for my degrees to cancel out. So that's negative 45 pi over 180. And you always want to reduce all these down. That's negative pi over 4. So this unit, you're going to basically learn how to go back and forth between degrees and radians. Okay, example 3, let's go the other way. So I've got 5 pi over 6, and I want to figure out how many radians it is. So my goal right now is to get rid of this pi in the numerator. So I'm going to need to multiply it by something where the pi is in the denominator in order for these two things, this and this, to cancel out. So pi is 180 degrees, because I need my pi's to cancel out. And then 6, hold on, let me change colors. 6 goes into 180 30 times, so it gives me 150 degrees. Let's try 4. Negative 3 pi over 2. Again, I want to get rid of my pi in the numerator, so I need a pi in the denominator in order for it to cancel. So 180 degrees to pi. that means my pi's will cancel. And then 2 goes into 180 90 times. So it's negative 270 degrees. Okay, next we're going to learn to convert into degrees, minutes, and seconds. So degrees, minutes, seconds. So when you see that notation, that means degrees, minutes, and seconds. So instead of saying like 25.63 degrees, they're going to put it in degrees, minutes, and seconds. So anytime that you see longitude and latitude, that is in degrees, minutes, and seconds. So, for example, there's 60 minutes in 1 degree. This symbol means minute. And then there's, oops, erase me. There's 3,600 seconds in 1 degree. And so this is seconds. Okay. But I'm going to show you how to convert these, and if you give me a second. Okay, also I've got to add one thing too, and also there's 3,600 seconds in 1 degree, but there's also 60 seconds in 1 minute. So you need that also to convert. Okay, so let's try a problem. I want to convert 56.735 degrees to degrees, minutes, and seconds. So you're going to separate this into 2. I'm going to separate it into the 56, which is the degrees part, plus the 0.735 degrees. And so I need to convert it into minutes. So this is going to be times 60 minutes in 1 degree, because I need to go to the minutes next. I already have my original degrees. That's the first part. This is the degrees. And so when I do that, that's going to give me 44.1 minutes. Okay? But you notice I still have a decimal left right here. So I'm going to convert that 0.1 minutes into your seconds. And so now I have 56 degrees, 44 minutes, and I have 0.1 seconds, which I want, or 0.1 as a decimal, and I want to turn that into seconds. So there's 60 seconds in 1 minute. And so that all comes out to be 56 degrees, 44 minutes, and 6 seconds. Oops. Oh, come on, right. For my answer. Okay, if you want to do this on the calculator, here are the steps to do it on the calculator. So for example, I have 329.125 degrees, and I want to change it to degrees, minutes, and seconds. You're going to hit the second button on your calculator, and then find the apps. This is on a TI-84 or an 83. You're going to look for where it says degrees, minutes, and seconds. And then it should give you 329 degrees, 7 minutes, 30 seconds. That's the calculator version. Next, we're going to go look at coterminal angles. So for something to be a coterminal angle, yeah, that means they're angles that have the same initial side and their terminal side even though it might be a larger angle, lies in the same place. Okay, so you might want to pause that and copy that down before going to the next screen. Okay, so let's take a look at a coordinate graph. If I put in a 45-degree angle right here, let's see if I can do this. Okay. That looks really bad. Let's try and make something straighter. Okay, so let's say I put in a 45-degree angle right here. Okay, so if I take that terminal side, hold on. If I take this 45-degree angle and I rotate it 360 degrees, it'll land here again. So if I have 45 and I go around 360 degrees, go all the way around, that's going to get me to 405 degrees. So if I go around one time, 405 will be coterminal to it. If I take this again and swing it around and add another 360 degrees, I'll get another coterminal angle. If I do it again and add another 360 degrees, I'll get a coterminal angle. I also will get one, let me change this to red, if I go in the opposite direction. So if I start at 45 degrees and I subtract 360 degrees, I'm also going to get a coterminal angle. So if I do 45 and I subtract 360 degrees, that's going to put me at negative 315 degrees. I will also have a coterminal angle. So whether or not I take, come on, let me get it, dude. Oh, it won't move anymore. Hold on. Okay, it won't let me rotate anymore. Okay, so anyway, whether I move, let me point the arrow to it. So whether I keep this here or I rotate it in a counterclockwise direction, that adds 360, or if I go in a clockwise direction, I subtract 360. So let's do another one. If I'm at, and you'll learn where these angles are in another class. So right now, this angle here, we're going to call 5 pi over 3. So I want to find a positive and a negative coterminal angle. So if I want to find a positive one, since we're dealing with radians, instead of adding, remember, before I went 360 degrees. Well, 360 degrees equals 2 pi when you're talking about radians. So I'm going to add 2 pi, and I'm going to subtract 2 pi. This is where you have to be able to add and subtract rational fractions together. So in order to add them together, I have to have a common denominator. So that 5 pi over 3, this is technically over 1. So I have to change this 2 pi over 1 to 6 pi over 3. 5 pi over 3 plus 6 pi over 3. Oops. Subtract. That's supposed to be a minus. Okay, so I want to find one positive, one negative. So when I add 5 pi over 3 and 6 pi over 3, I'm going to get 11 pi over 3. That's from this one. And when I do 5 pi over 3 minus 6 pi over 3, we're going to get negative pi over 3. That's from this one. And those are just two of the coterminal angles I can find. Okay, now we're going to look at arc length. So your arc length is just the length of this arc outside here. So if you remember from geometry, you always did the formula for circumference of a circle times the degree of your angle divided by 360. Well, in pre-calculus, we're going to do S equals r theta, where S is your arc length, r is your radius, and the theta is in here, and theta is in radians, so meaning it has to have a pi in it. So if you're given your angle and degree, you have to convert it to radians. Okay, so now we are going to find let me change it to green, the arc length when my radian is in pi over 4 and my radius is 5. So my formula is S equals R theta. So my radius is 5 and theta is already in radians, so I don't need to convert anything. So it's just times pi over 4. So when you multiply that out, that's 5 pi over 4. And if you were to put that in the calculator, that's about 3.9. And that would be the length of this in centimeters. Okay, this next one, I'm giving to you the angle in degrees. So first thing we need to do is we need to convert 60 degrees to radians. So to do that, you're doing 60 degrees. And remember, we need this degree to disappear, so I'm going to put the degrees on the bottom and pi on the top. So that way my degree cancels out and I'm left with radians. 60 goes into 183 times, so that's pi over 3. So the 60 degrees in radians is pi over 3. So for my arc length, my radius is 2. My theta this time is pi over 3. And so that arc length here is 2 pi over 3, which is about 2.1, let's call the centimeters, inches, whatever the units are, 2.1 units. Okay, now we're going to find area of a sector. So if you remember, area is basically the area of this length. So you're doing part of an area of a circle. So the formula for area of a sector is 1/2 r squared theta. And again, your theta needs to be in radians, not in degrees. So let's do green. Okay. So this is my radius, this is my theta. So my area equals 1/2 my radius squared times my theta. So 1/2 of 9 times 7 pi over 8. That's going to give me 63 pi over 16, which is about 12.4. Okay, so this theta kind of takes into account, if you know a circle, that basically is pi r squared, and you're basically doing part of it. You're doing 7 pi over 8 over 2 pi parts of it. So if you forget your formula for this, go back to your days of geometry and do pi r squared and figure out what fraction of the circle 7 pi over 8 over 2 pi is, and that will end up giving you the exact same thing. Next, we're going to look at linear and angular speed. Linear speed measures how fast something is moving along an arc. So my formula for linear speed is V equals, officially it's S over T. And your S is your arc length, so it's kind of like your distance over your time. And so that is R theta over T, which is your arc length over time. Kind of like, think of it like you're working backwards from distance equals rate times time. So your V is your speed. Here's some other ways to think of it as you're doing problems. So your linear speed oops, I can't spell speed right. Let me do that again. Okay, so there's a couple different ways to think of this when you're doing it. It's going to be your angular speed, which we're going to talk about, times your radius. Or think of it as 2 pi times your number of revolutions times your radius. Move this up, times your radius. Okay, or 2 pi times your number of revolutions is your circumference or sorry, 2 pi times your radius is your circumference times your number of revolutions. So depending on what kind of information you're giving, all of those things basically are linear speed. Angular speed measures how fast your angle is changing. And so it's got a funny little symbol. It looks like this. Hold on. Kind of looks like a W. It's just theta over t. So basically it's kind of like your linear speed without your radius. So your linear speed without taking into account your radius. So you're basically just figuring out how much the angle is changing. So it's whatever your central angle is over your time. And so usually all you're going to have to do is just figure out 2 pi times how many revolutions you went. Okay, a bicycle tire rotates at a rate of 140 revolutions per minute. Find the angular speed of the tire in radians per minute. So, my formula for my angular speed is that weird little W shape, theta over t, okay? So in this case, we're just doing it per minute, so my time is 1. Now your theta is going to come from 140 revolutions. That means you're going around your circle 140 times. So you're doing 140 revolutions, and each one of those is 2 pi. So my angular speed, remember speed doesn't have anything to do with the radius, is going to be 280 pi radians per minute. That's what my angular speed is going to be. If the tire with a radius of 15 inches turns at a rate of 2.5 revolutions per second, I want to know what the linear speed is. So basically your linear speed, is your V equals your S over your T. If you kind of think back to your distance equals rate times time, it's your distance, your S equals your rate times your time. And in this case, your distance is going to be, hold on, let me change my pen to fatter, is your R times your theta. That is your distance that you're basically going to go. Your radius times whatever your angle is over T. And in this case, your theta, you're going to get by doing your number of revolutions. So that's how many times you're going to go around your circle times 2 pi. Because each time you go around your circle, it's going to be 2 pi. So if I go around 20 times, you do 20 times 2 pi, and that figures out what that distance is that you went around your circle, divided by your time. So now my linear speed, my radius is 15 inches, and my theta, I went around 2.5 times, so 2.5 revolutions per second, times my 2 pi, and all of that, and they're talking about per second, so that's basically, we're just going to move this per second down here. So you're doing 2.5 revolutions, so there's your revolutions per second. The per second we just moved down here. And really, since this is a 1, we're really not going to have to worry about this. So that means my V, let me change colors. My linear speed is going to be 15 times 2.5 times 2 pi is going to give me 75 inches per second is how far I go. And so if I want this in my linear speed, let's say I want my linear speed in miles per hour. Okay, so let me change colors. Let's go to orange. Okay, so there are, in 1 minute, there's 60 seconds. That way I get rid of my seconds. So now I have inches per minute, but I need miles per hour. So there's 60 minutes in 1 hour. So I have my hours part. So that part's done. Now I need to convert my inches into miles. And so there are 1 foot and 12 inches. And then 1 mile is 5,280 feet. So now I'm left with, let me use a highlighter. And let's make my highlighter yellow. Okay. So now I have my hours and I have my miles. So I have my miles per hour. And if you give me a minute, let me see if I can shrink this. Okay. Alright. Just trying to shrink this so I can fit it in here. Okay. So now let's go back to my pen. So 75 times 60 times 60 all on the top is going to give me 134. When I divide that by the 12 times the 520, you end up with 134 miles per hour if you reduce it. So all I did was just multiply everything out, divide by the 5,280 divided by 12, you get 134 miles per hour. So if I want to find the angular speed of a DVD whose radius is 120 millimeters in radians per second if the disk is rotating at 3.5 revolutions per second. So if I want angular speed, the only thing that I need to know is basically theta, which is my angle that it rotates over time. I really don't need the radius yet. We'll use this on the next problem. So this is going to be for the next problem. We don't need it on this one. You only need that if you're going to do linear speed. Your angular speed is how much your angle is changing. So my angle is going to come from doing 2 pi times however many revolutions you have. And we're doing that per second. So if I multiply that all out, 2.5 times 2 is going to give me 7 pi radians per second. That is going to be my angular speed. If the DVD overheats and begins to rotate at a slower 3 revolutions per second, find the linear speed. So my linear speed is going to be my r times my theta over my t. You have to take into account your radius. And this time my radius, remember it was 120 millimeters, which 120 millimeters is equal to 0.12 meters. So it rotates, or the radius is 0.12 meters. And my theta is 2 pi times my 3. And that's over 1 second. Because it's 2 pi, or it's 3 revolutions. It's 3 revolutions per second. So when I multiply 0.12 times 2 times 3 is 6. That's 0.72. That's going to give me 0.72 pi meters per second. But I want it in meters per minute, so I need to multiply by, there are 60 seconds in 1 minute. That way my seconds cancel out. And that's going to give me 21.60 pi meters per minute. Now if you multiplied out the 21.6 times the pi, that would be fine too. If you leave it in the pi, that's also fine.